In the last episode, we ended the episode with just the largest structures of the universe that we know of in the universe, which are superclusters. And today, we're actually going to focus on, compared to that, something so tiny, it's just insignificant. But to us, that insignificant little tiny object is everything that we have. And I'm not even talking about the Earth, I'm talking about the entire solar system. So today I'm going to go into the sun and its life, starting from the beginning of its life until the far future, which will be the end of its life. In this episode, I'm going to talk about it kind of in a storybook form. I'm going to kind of give the sun some personification, which I think will be fun. But to start, we're going to talk about how old the solar system is. And the way that we kind of found out about how old it is were by looking into the oldest inclusions found in meteorites, which are calcium aluminum rich inclusions, and they are probably the oldest substances in the solar system. They are thought to trace the first solid material to form in the pre-solar nebula back to 4.6 billion years ago. So that's probably how old the solar system is. Studies of ancient meteorites reveal traces of stable daughter nuclei of short-lived isotopes, such as iron-60, that only form exploding, short-lived stars. This indicates that one or more supernova occurred near the sun while it was forming. So yeah, the information that we got says that the solar system dates back about 4.6 billion years ago. So now that we got that out of the way, I think we can start getting into the storybook side of it, and the personification of the sun, which I think will be fun. And yeah, we'll get into that right now on Down the Line. Welcome back to Down the Line. I'm your host, Pete, and this episode, like all the other ones so far, is going to start off in space. And in space, there's this giant molecular space cloud. And what happens next is what we call the Nebular Hypothesis. It's the most widely accepted model in the field of cosmology to explain the formation and evolution of our solar system. And basically what that says that happened is that the solar system formed from the gravitational collapse of a fragment from this giant molecular cloud. One of these collapsing fragments led to the formation of the solar system. So there's this giant space cloud, and for some reason it just collapsed, and this little piece of it spreads out, goes far away from it, and that's what ended up becoming our entire solar system. Gravity pulled together low-density clouds of interstellar gas and dust called a nebula, and because of the conversion of angular momentum, the nebula starts spinning faster as it collapsed. The center, where most of its mass collected, became increasingly hotter than the surrounding disk. The competing forces of gravity, gas pressure, magnetic fields, and rotation caused the contracting nebula to flatten into a spinning protoplanetary disk and form a hot, dense protostar at the center, and that is the birth of our star. So you take this giant molecular cloud, that a piece of it falls off, and then it starts, combining and compressing, and then there's all this space dust, and out from this fucking dust, our hero rises from the fucking dust like a phoenix. And I say our hero like it's everyone's hero. If you're someone that's like, oh, fuck the sun and it's too hot, it's like, shut the fuck up. Like, I like winter better. It's like, dude, come on. Right, anyway, sorry, I get a little sidetracked. So what happens after that? The sun single-handedly fights off like 10 ninjas. Now, that obviously didn't happen. That would make no sense. Actually, what happened after that is nothing for like 50 million years. Hydrostatic equilibrium was achieved after that, about 50 million years. And hydrostatic equilibrium is the balance between gravitational force and internal pressure. And this marked the sun's entry into the prime phase of its life. So it's gone through like puberty and shit like that, and now it's at adolescence. And this goes on until its retirement. And this phase of its life is known as the main sequence. And main sequence stars derive energy from the fusion of hydrogen into helium in their cores. And the sun remains a main sequence star today and will for a really long time, probably. Well, not probably, for sure will remain this way for a very long time. And so that's basically what all it does, is it just burns hydrogen into helium in its core. So we're going to go from there into the formation of the planets. So I guess like the planets, if I think about it in a personified way, would be like the sun's kids, probably. I don't know. I'm just thinking about it in nonsensical ways now. Well, the various planets are thought to have formed from the solar nebula, the disc-shaped cloud of gas and dust left over from the sun's formation. So all that dust that, the sun rose from like a fucking phoenix, that's now spreading out, and then the planets shape from that, like little baby phoenixes from the original I don't know what the fuck I'm talking about. The currently accepted method by which the planets formed is accretion, in which the planets began as dust grains in orbit around the central protostar. Through direct contact, these grains formed into clumps, which in turn collided to form larger bodies. So there's all these dust particles that are just floating around the sun in that little nebula, and they start to combine together and make little clumps, and these clumps will crash into other clumps to make bigger, forms of rock. And then these bigger rocks just keep crashing into each other, and that just keeps making bigger and bigger, sized planets. Not even just planets at this point; they're more just like, giant rocks. The inner solar system, the region of the solar system inside 4 astronomical units, was too warm for volatile molecules like water and methane to condense, so the planet simals that formed there could only form from compounds with high melting points, such as metals, like iron, nickel, aluminum, and rocky silicates. These rocky bodies would become the terrestrial planets of Mercury, Venus, Earth, and Mars. These compounds are quite rare in the universe, comprising only 0.6% of the mass of the nebula, so the terrestrial planets could not grow very large. Subsequent collisions and mergers between these planet-sized bodies allowed terrestrial planets to grow to their present forms today. Now we go into the giant planets, which are Jupiter, Saturn, Uranus, Neptune, a lot of crap. They form further out, obviously, beyond the frost line, which is the point between the orbit of Mars and Jupiter, where the material is cool enough for volatile icy compounds to remain solid. The ices that form the Jovian planets were more abundant than the metals and silicates that form the terrestrial planets, allowing the giant planets to grow massive enough to capture hydrogen and helium, the lightest and most abundant elements. So they're obviously not rocky; they're the gas planets, and they're the gas planets because they're capturing lighter elements, as opposed to like Earth, which are capturing metals. As the earlier Jovian planets captured large amounts of gas, the same process that formed the solar nebula, contraction, spinning, flattening, and heating, formed similar but smaller disks of material around these planets. Condensation and accretion took place within the Jovian nebula, creating a miniature solar system around each Jovian planet. These mini-planets became the solar system moons. So I'm going to go back to, if you think about the sun as the main character or whatever, the planets are the kids, and then the solar system moons would be like its grandkids. And as I'm thinking more about it, it makes so little sense to use the sun as like a stage of life. I guess the more common, or not the more common, but the best way to think about how the sun works is to kind of think of it like a car that has one tank of gas, and that's all it has. And once you start running out of gas, your car still tries to pump through it until it literally just has no more. But going back to the moons, anyway, I just kind of got off topic again. But I thought that was like a better way to think of it than to think. I just like personifying it. I think it makes it, I wouldn't say relatable, because, I mean, can you relate to the sun? Probably not, but it just makes me think about it in a way that makes more sense to me, I guess. But going back to the moons, some planetimals collide with planets. And Earth, was probably hit by a Mars-sized object, ejecting debris that coalesced to form the moon. So not all the moons were just formed by Jupiter and these little planets having their own little solar system around these big gas planets. Some of them crashed into terrestrial planets. For example, like something hitting Earth, making our moon. And yeah, so right now, if we think about the sun in life terms, the sun was born, had a couple kids, which are the planets, had some moons, had a couple grandkids, and now it's at retirement age. And this is the future of the solar system. So we're at a point right now that is past our current day future. Astronomers estimate that the solar system as we know it today will not change drastically until the sun has fused almost all the hydrogen fuel in its core into helium, beginning its evolution from the main sequence into its red giant phase, which are luminous giant stars of low or intermediate mass and a late phase of stellar evolution. So let's say at this point, the car that is full of fuel is now starting to run out. So maybe the gas light's gone on now. In the long term, the greatest changes in the solar system will come from the changes in the sun itself as it ages. As the sun burns through its supply of hydrogen fuel, it gets hotter and burns through the remaining fuel even faster. As a result, the sun is growing brighter. As the sun's radiation output increases, its circumstellar habitable zone will move outwards, making the Earth's surface too hot for liquid water to exist there naturally. At this point, all life on land will become extinct. Evaporation of water, a potent greenhouse gas from the Earth's surface, could actually accelerate temperature increases, gradually ending all life on Earth even sooner. So, the future of the solar system does not look that good for the Earth. Around 5.4 billion years from now, the core of the sun will become hot enough to trigger hydrogen fusion in its surrounding shell. This will cause the outer layers of the star to expand greatly, and the star will enter a phase of its life known as a red giant. As a result of the vastly increased surface area, the sun's surface will be much cooler than now and its luminosity much higher. As the sun expands, it will likely swallow the planets Mercury and Venus. Earth's fate is less clear, although a 2008 study suggests that Earth will likely be swallowed up as a result of tidal interactions with the sun's weakly bound outer envelope. So, if by that point, I guess all life on Earth will be gone anyway, but if you're thinking, oh, maybe we'll get into another point where life will begin again, probably not, because the sun is going to cannibalize its kids, like fucking, was it Greek? I think so, right, with Zeus and all them being eaten by the Titan, which is super fucked up and weird. They had some weird religions. Not that our religions today aren't kind of like amazing to believe, and I don't mean that in a bad way. I mean they're just crazy, like stories, you know, like that just not sound good to me. I mean, like, they're just interesting stories, and the ones from before Christianity were more interesting in like a way less believable way, where you're just like, oh, these gods had these parent gods that, you know, ate. I don't know, I'm way off topic now. I don't know, I get easily distracted. It's just funny to me that, like, when I think back to those kind of beliefs, like the Greek and Roman, and I'm like, how did people believe that? And like, I know some people still think that today, and I wouldn't really call myself a believer, but like, I grew up believing it, and I read from the Bible, and I, you know, looked into the Torah and even the Quran, and I tried to make sense of it, and I kind of came to the conclusion that I didn't really think I believed it, but I don't know how to explain it. Like, it doesn't amaze me that other people believe it as much as like I said, the Greeks, and I'm like, how the fuck did anybody ever believe that? And I guess it's just like the lack of science back then that would make people not really understand the way things worked. Like nowadays we have we're able to be like, that makes no fucking sense, you know? Anyway, going back to the star right now. So where I last left off, the sun was in the process of cannibalizing its own kids. Gradually, the hydrogen burning in the shell around the solar core will increase the mass of the core. At this point, the density and temperature will become so high that the fusion of helium into carbon will begin, leading to a helium flash. The sun will then shrink, and its surface temperature will increase. The sun will become a horizontal giant, burning helium in its core in a stable fashion, much like it burns hydrogen today. So the sun has gone through all of its hydrogen supply, and instead of converting the hydrogen into helium, it's converting helium into carbon. So now it's running through its helium supply. So the sun is getting old, and it's getting to the end of its life right now, at this point in, you know, the narrative. Eventually, it will have to again resort to the reserves of hydrogen and helium in its outer cores, or outer layers, and will expand a second time, turning into what is known as an asymptotic giant. I have no idea if that's how you pronounce it. It's like, it's asymptotic, asymptotic, I think, asymptotic, fucking, the sun's remaining outer layers will fall away, ejecting a vast stream of matter into space and forming a halo known as a planetary nebula. The ejected material will contain the helium and carbon produced by the sun's nuclear reactions, continuing the enrichment of the interstellar medium with heavy elements for future generations of stars. So towards the end of its life, it's going to just give off all of a bunch of metals and heavy elements that can hopefully give life to new stars in the future. Afterwards, all that will remain of the sun is a white dwarf, an extraordinarily dense object the size of a terrestrial planet like Earth. So now the sun is like on its deathbed. It'll consist of entirely degenerated carbon and oxygen, but will never reach temperatures hot enough to fuse these elements. Thus, the white dwarf sun will gradually cool and grow dimmer and dimmer. Eventually, after billions of years, the sun will finally cease to shine altogether, becoming a black dwarf. And that's the end of our story. That's the death of a hero. If you think this episode was depressing, next episode is probably going to give you some existential crises. Next episode is actually going to be on... So there are 3 ways that the Big Bang Theory has an end for the universe, and they're all like really scary, like horrible ways that the universe will end. They're not really like technically horrible. To us, they'd be horrible, like fire and fucking destruction. But yeah, I just like think it's interesting to think about it in terms of, you know, with the Big Bang Theory, the universe we've always thought was infinite, and for the beginning of it, we now know that there was probably a beginning. It was probably very, very small and expanded. And now we kind of have ideas for how it actually might end. So the universe itself is, I guess it's a life like any of us. You know, we have a beginning, we have an end. And the universe probably does too. And in my personal belief, just from what, I guess it's not like any scientifically held backing or anything. It's just a personal belief. But I think that when when the universe dies and finally gives out, I think that when it dies, I think another one is born. And I think it's just an infinite cycle. I think we're I don't think we're the first universe, and I don't think we'll be the last universe. I think it's just when the universe starts from this little tiny thing and it just grows out, and then when it dies and it's just this big empty space, I think another one comes from it and starts expanding, and it just goes on forever and ever into that space. All these stars and galaxies just, you know, once the universe is completely dead, they just keep coming. But I kind of think in a way that that's kind of a beautiful way to look at it. It's like reincarnation, like for a universe, and there's always going to be life, and it's always going to die, because things always will come to an end. And we're just, you know, we're just stardust. That one cool way that I think to look at it, that I actually got from, I think it was called In a Nutshell, was that we are the eyes of the universe kind of observing itself. So like we are the way for the universe. It's kind of like the idea of like Jesus is God's son, and he is the human version of God who's, you know, able to interact with his creations. And I kind of think that's what we are to the universe. I think the universe, you know, made us so that we can observe itself. Like we were observing ourselves from a different perspective. So that's what I think our purpose is in life. And I think aside from that, I guess your purpose would be just to make life what you want it to be. You know, do what you like to do, and not just you in general. Do nice things for other people. And I think as a whole human race, and just as animals ourselves, to just live good lives and just be happy. I can't think of any other way to end an episode than that. Just be happy and do what you like and do good things for people. And yeah, so next episode's gonna be pretty dark. So maybe this is a good way to end it, like a little positivity. And I'll probably end it positive next time too. But thank you guys so much for watching and hearing the little story about our son and the life from beginning to end. I think it was really cool, a little structure. I went off topic a lot of times, but I think it ended up pretty good. So I'll see you guys next time when we talk about the end of the universe.